All right, I want to take a look at this midterm for Calc 1, show you how we do the problems, and maybe talk about some of the things that went wrong. Um, Problem number 1, limit as x goes to 4. First thing, of course, is you try plugging it in. Clearly, there's a 0 on the bottom, 4 squared minus 16. But if there's not a 0 on the top, then I would say it does not exist. But when I plug a 4 in on the top, I've got 16 plus 8 minus 24. So that's a 0 divided by 0, which means I need to do more work. But it also means I know that one of the factors of the top is x minus 4. Likewise, because there was a 0 on the bottom, x minus 4 is a factor of the bottom. So I factor the top into x minus 4, x plus 6, and I factor the bottom into x minus 4 times x plus 4. X minus 4's cancel out. There's the 0 divided by 0 canceling out. Now I can plug the 4 in, and I get 4 plus 6 is 10, and 4 plus 4 is 8, so 10/8, or which reduces to 5/4. That was mostly gotten correct. This one, number 2, again, try plugging it in. It is a 0 divided by 0 when you plug the x equals 1 in. So I opted to factor the bottom into square root of x minus 1, square root of x plus 1. The square root of x minus 1's cancel out, leaving just a 1 on the top, a factor of 1 on the top, and we got a factor of square root of x plus 1 on the bottom. Plug the 1 in now. There's a 1 on the top. There's a square root of 1 plus 1 on the bottom. That would be 2. So the answer is 1/2. Again, I think most people got that one right. Number 3, as x goes to infinity, this looks like an infinity over infinity. And the way we've been doing these is to say, hey, when x is really big, the 200s are relevant. The 5x and the 10x are irrelevant compared to those x squareds. So you're looking at 3x squared over x squared, which would be 3. When x is headed to infinity, this looks like 3. Okay. Definitions. I said you needed these definitions. What's the definition of limit? Well, L is the limit of f of x. If for each epsilon bigger than 0, there exists a delta such that if 0 is less than f of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. All right, that's the epsilon delta definition of limit. I wanted to see that. That's the definition. If you said, well, you gave me the informal definition, I maybe gave you some of the points. Which, by the way, the points were 5 points each, and there's 18 questions. That adds up to 90 plus 10 points for your name, for a total of 100. So on each page, you should see how many, well, besides each question, you should see how many points you got subtracted. The bottom right corner of the page would be how many points you got off for that page. If you add up all those numbers in the bottom right and add them to 100, that should be your score. So anyway, what's the definition of continuous? Function is continuous at a if f of a is equal to the limit of f of x as x goes to a. Right. That's the definition. What's the definition of derivative? Well, given a function f of x, the derivative, f prime of x, is the limit as h goes to 0 of f of x plus h minus f of x all over h, provided the limit exists. I also accepted the other definition, the limit as x goes to a of f of x minus f of a over x minus a. That was the derivative at a point. This is the derivative of the function. I accepted either one. Use the intermediate value theorem. You had to show me you knew what the intermediate value theorem was. Right, the intermediate value theorem is a theorem about continuous functions. So first of all, we're going to point out that this function, being polynomial, is a continuous function everywhere. So in particular, it's continuous on the interval between 0 and 2. I notice that the function value at 0 is -1, and the function value at 2 is 9. Right? So here we're down at -1. Here we're up at 9, and my pen's not writing all of a sudden. And so the claim is that somewhere we have to pass through 0. Well, I need to mention that this is a continuous function, because if it isn't a continuous function, maybe the function is down here and then all of a sudden jumps up there and never hits 0 somewhere in the middle. But because it's a continuous function, it has to, and that's what the intermediate value theorem says. The intermediate value theorem says that the function takes on every value between the y value at the start and the y value at the end. In particular, here it must take on the value 0 somewhere on that interval. Okay. So I was looking to see that you checked the endpoints. I was looking to see that you mentioned, hey, that this is a continuous function, and then quoting the mean value theorem. Intermediate value theorem. Mean value theorem coming up later. I'm going to switch to a different pen here. Use the definition. All right, so on this one, I'm opting to use the definition at a point. So I'm taking the limit as x goes to 2 of f of x minus f of 2 all over x minus 2. You could have done this with the x plus h thing and then plugged, so essentially 2 plus h. Right? Plugging stuff in here, this is the f of x is the square root of 3x. F of 2 is, well, plug a 2 in there, so it's square root of 6. I'm going to multiply top and bottom by the conjugate of that numerator, so multiplying by 1, not changing the value, just changing what it looks like. When you FOIL the top out, there's 3x, there's a plus those two square roots, there's a minus those two square roots, they go away, and then you get the minus 6. So the top turns into a 3x minus 6. The bottom I'm going to leave factored, don't multiply it out. And the thing is, I know why I did this. I'm expecting a nice factor on the top to cancel out that x minus 2 on the bottom. And sure enough, the 3x minus 6, the 3 can be factored out to 3 times x minus 2. And then the x minus 2's cancel out, leaving a 3 on the top and a square root of 3x plus the square root of 6 on the bottom. Now when I plug the 2 in, I've got a square root of 6 plus the square root of 6 on the bottom. So 3 divided by 2 square roots of 6. Which was about 0.61237. If you use the shortcut rule to take the derivative and plug the 2 in, I did not give credit for that. I asked you to use the definition. All right, you got to use the definition. Use the definition to find the derivative of the function here, 2x. So here's the definition of derivative. For this function, f of x plus h is 1 over 2 times x plus h minus f of x, which is 1 over 2x. So subtract those all over h. I am going to make this a smaller fraction by multiplying by 1 in the form of, look at all of the denominators. There's a 2x plus h and there's a 2x. Well, so if I multiply by all those things, I can cancel everything out. There's a distributive property. It's going to multiply this here and that there. So the first one, the 2's cancel out, the x plus h's cancel out, you're just left with an x. And you multiply by the second one here, the 2's cancel out, the x's cancel out, you're left with an x plus h, but there's a minus sign in between. And everything is still down on the bottom here. Distribute the minus sign through, the x and the minus x go away, and you just got a minus h left on top, but that minus h is going to cancel with this h on the bottom, leaving a minus 1 on the top and a 2 x plus h and an x on the bottom. But as h goes to 0, that x plus h turns just into x, so that becomes an x squared. So minus 1 over 2x squared. Okay, again, you had to use the definition. If you just use the power rule or quotient rule or whatever, I did not accept that. I wanted to see you use the definition. Number 10, draw the graph of the derivative. So at each point over here, you should tell me what the slope is over there. So notice, to start with, this is headed uphill, has a positive slope. So you needed to start off with something positive. And then the slope is getting less, down to a point right here where the slope is 0. Now, I tried to draw a parabola, and I drew it by hand, so it isn't perfectly accurate. But some people might have thought that this looked like maybe like a sine curve, or an upside down sine curve. If it was a parabola, the derivative should be a straight line. So I had figured on that there's a positive slopes coming down to 0, and then negative slopes. So I was picturing something like this. However, if you saw that as like a sine curve, then you might have said, hey, this looks more like a cosine curve. So you might have drawn something that looks like this. Or you might have drawn something, and if you saw it some other way, you might have drawn something that looked like that. The point is, I needed to see that you could tell that it started off with positive slopes, that it got down to 0 slope, and then it got down to negative slopes, so that this was in a downhill direction here. The exact shape of it, I wasn't worried about. Now, because I drew this kind of goofy, some people noticed that it didn't just come down like a normal parabola would. It kind of smoothed itself out a little bit. So there were some people that actually brought this down saying, hey, it's steeper and then less steep. So they brought this back up like this, which was fine, right? It didn't mean to draw it that way, but that's the way it looks. So it came back up like this. And then you get to this spot right here where it's all slope -1. It's a straight line, slope -1. So this should be right here at -1. Now I was thinking there was a sharp corner there, but again, because of the way I drew it, if you smooth that out, that's fine. But here, there definitely is a sharp corner. You go from a slope of -1 suddenly to having a slope of 2. So this pops from -1 up to 2 and with an open circle there. And then it's a straight line, same slope all the way through that. So the slope is 2 all the way through that. Then suddenly there's a sharp corner and we have slope of 0 right down here. And some people said, well, it's going uphill just a little bit, and they drew that above 0 a little bit. I was fine with that. Okay. I was looking for several things. I was looking for positive to 0 to negative somehow through here, straight line of slope 1, straight line of slope 0 or slope 2, and then straight line of slope 0, right? Number 10. Number 11. On these, you didn't have to use the definition. You could use anything you wanted. This was just take the derivatives. Let me show me that you know how to do the process of taking derivatives. So these are power rules, right? This is a sum. So take the derivative of each piece, add them up. This is 3x squared minus 10x. This one was a little tricky. This is x to the 1/3 power. So the derivative is 1/3 x to the 1/3 minus 1, and 1/3 minus 1 is minus 2/3. So this is x to the minus 2/3, right? Some people didn't get that subtracted right. Anyway, and then the derivative of the plus 8 is 0. So there's a plus 0 on the end there. This one's a quotient. You got to use the quotient rule. Bottom squared, bottom times the derivative of the top, minus top times the derivative of the bottom. Okay. Careful with your algebra. I had so many people canceling this and that out. It's like they don't cancel out. This is not multiplied by the whole top. There's a minus sign right here. This just it doesn't cancel out. You've got to get to the point where you're doing your algebra correctly, because otherwise you're going to think you don't know how to do calculus. It's not the calculus, it's the problem here. People got the quotient rule right and then did bad algebra. Okay. Yeah, this could be multiplied out and some like terms could be collected, but I wasn't worried about that. This one, I got people thinking that sine to the -1 power means 1 over sine, like cosecant or something like that. No, this means inverse sine. This is the arc sine. And so either you remember how to take the derivative of an arc sine of something together with the chain rule, or you would say the sine, take the sine on both sides. So the sine of y is 2x, and then implicitly differentiate. The derivative of sine y is cosine y times dy dx. The derivative of 2x is 2. So dy dx is 2 over cosine y. But cosine y, let's come back here. There's a triangle. If y is the angle whose sine is 2x over 1, and the other side here is going to be 1 minus that squared, so 4x squared. Notice that's the same square root I started with, so that's good. And the cosine of y is the square root divided by 1. So 2 over the square root of 1 minus 4x squared. That's what I have for an answer. Okay. If you're not seeing what's going on here, what's the difference between sine to the -1, which is arc sine or inverse sine, and 1 divided by sine x, come talk to me. This is important that you know what our notation means. This is not cosecant. This is arc sine. And I'm going to stop this video right here because I'm about out of time, and then I'm going to finish this on another video.